Friends, it's great to be here and get together to discuss about the fascinating, complex, sometimes frightening, sometimes illuminating aspects of the current world. And mathematics was designed to describe the world, to understand the world, to act upon the world. Many people think that mathematics is so damn complicated. But as John von Neumann put it once, it's not that mathematics is complicated. It's the world which is so complicated. So much more complicated than any mathematical theorem you can think of. Many people think of mathematics as something which has been mostly done in the past, and in which only a few questions remain to be treated. But people in mathematics know very well that progress in mathematics has been amazing in the past few centuries, that it is now faster than ever, and that the more discoveries you make in mathematics, the more problems arise. Fascinating problems, riddles, and enigmas. And for many people, fighting against these riddles, going into the unknown, is main motivation for going into science. When I was a teenager, 30 years ago or so, I was fascinated by these riddles and the way mathematics would combine with other features of the world. Reading such authors as the great Douglas Hofstadter, one of the masters of mathematics outreach. It is in his books that I first heard about Alan Turing. It's very good to celebrate his memory in this country. In the 80s was the time of the amazingly good biography by Andrew Hodges that appeared and unveiled the mysteries about him and revealed how this man had made so much for science and for the world, for development of computer science, for helping the war coming to an end, etc., etc. And also in those books, it was about artificial intelligence, a subject of understanding how our brains work, what's the secret behind the reasoning and understanding, and so forth. A lot of relation to logic, some strange languages. It was fascinating for the teenager that I was, and certainly one of the motivations for me to go into mathematics. However, after I went through the very elitistic system of mathematics in France, maybe one of the most elite or the most elite in the world, when I was in École Normale Supérieure, our professors certainly did not advise us to go into artificial intelligence. The subject looked as a subject which has almost no results for a few dreamers that were very much interested in logics and the deep nature of things. And of course, there were some exceptions to that, but I went into, instead, mathematical physics. The mysteries of understanding the physical world through mathematics, think that a discovery such important as the atomic nature of the world, the fact that matter is made of atoms, was made through a combination of physics and mathematics and chemistry, observations of the trajectories of tiny particles wandering inside water. And people discovered a bit more than 100 years ago that the world is made of atoms without anybody having seen any atom. Here you see the magic of mathematics, giving you tools to go beyond the common sense, beyond the intuition. In the same way as 2 years ago, people, by matching the tiny, tiny variations of length, of time-space that occur when we are traversed by a gravitational wave, and seeing that the profile of these oscillations matches exactly what was computed by mathematical physicists, they found the best proof to this date of the existence of black holes and of the fact that it happened billions of years ago, that black holes collided and made an enormous chaos in the universe billions of years ago. These are things that you cannot imagine without mathematics. These I found so fascinating. I went for years into the world of cooperation of mathematics around the world, fighting theorem after theorem, unknown after unknown, made my way into it, and as Carlo mentioned, was awarded the Fields Medal eventually. This was on 19 August 2010, and it's the kind of date that you never forget. Recognition of outstanding work that you did with your collaborators and enormous fight against the unknown. Very much convinced that it was important to share about the science developments and to share about the passion of science with the society, I became very much engaged in talking, in doing outreach talks, in helping various institutions, helping projects such as European Union and Construction, became member of the first version of the scientific board for the European Commission. It was a disaster. One of the worst I ever was in. Went into the second instance of the scientific board because I'm very much, tenacity, and this one was working much better, and so on and so forth. Eventually, 2017, I made the move that going into the political life and becoming elected as a member of parliament to bring the science expertise into the politics. If you listen to what the first round table was telling us in terms of the status of politics nowadays, with a whole lot of distrust, hatred, confusion, you think you would have to be crazy or masochistic to go from the science world, in which it's all about world cooperation and people trusting you, to the politics world. But I deeply believed that it was important to bring this expertise to the politics at a time in which big political problems have never been so close to technological development, being to regulate or to develop, to make it so that technology is part of the solutions and not just the problems. I was in charge then of drafting the national strategy of artificial intelligence for France. UK already had a strategy, was the first country in Europe to have it. France wanted to go into it, and most importantly, to drive the start of a European strategy about it. You know what? AI had completely changed from the time that I was reading about it as a teenager. Total change. Was not so much now about logic than about finding the right data sets, the examples with which you can train algorithms, you can train machines so that they will automatically find what is the right way to find a solution or the analysis to a problem. Alan Turing now was no more an unknown person, had made very famous, in particular by an amazingly bad Hollywood movie that was taken from the amazingly good biography of Andrew Hodges. And artificial intelligence was no longer thought as a subject without application. On the contrary, everybody was talking about artificial intelligence, how it would change the world. And the efficiency had changed so much. Nowadays, you have algorithms that will automatically perform a number of sophisticated tasks that you would believe a priori are reserved for intelligent beings. Tasks such as recognizing from a medical image whether there is a disease or not, whether there is cancer or not, a task that it would take a human lots and lots of years to perform accurately and safely. Now these tasks, the algorithms will do as good as the best humans experts in this. Tasks such as driving a car automatically. While on these subjects, sometimes progress goes faster than expected, sometimes slower than expected, but there's no doubt that one day there will be automatic cars that will be much safer than the current cars and will be much more optimized in terms of consumption of energy and so forth. Or applications such as the helping people to fight for the environment, saving energy production, testing biodiversity, giving tools to help finding where are the best places to put solar panels and so on. On the other hand, AI so far has been disappointing in things such as education, how to help our teachers teach kids in the right way, or getting people trust within each other, confidence. On the contrary, it seems that all our efforts in technology to bring people together so far have in large part failed. You know, internet and massive social networks communication was supposed to bring education and communication to the whole world, to put people together. On the contrary, we have seen the rise of so many fake news, so much hatred. I tell you, as a politician, when you think of Twitter, you don't think of it as a way to see revelation, but you think, what today will be the attacks and the insults that I will receive through Twitter? And that is the way somehow technology, in the end, did not react with respect to us the way we believed. Not because of technology, because of us. In this context, it was important for the French government to find a roadmap to organize how to help capitalize on the great French assets, and in particular, the great amount of training, of research in mathematics, and so on. You know that France is the country with the highest number of rewards in mathematics if you take respective to the population, and even in absolute terms, second highest. And of course, the quality of research in mathematics and training is one of the reasons why so many international companies open up laboratories within France to help the development of algorithmics. On the other hand, you cannot just base a policy on AI and the research. You also need to think of the training, the education, the environment issues, the social evolution, how to organize the work in a world in which everybody may be someday helped by an algorithm, an AI, for more efficient work. We need also to think about the ethics, to think about the industry, how to help the sorry guys. Yes, there's some water here. Help about the health sector, the transportation sector, the environment sector, the defense sector, and so on and so forth. And so my report was aimed into providing a panorama of all that and start the policy. The report was presented to the French government on the same day that President Macron announced the roadmap for France, and on the same day there also was an international panel of experts coming from around the world in discussion with French politicians. One of them will be speaking in a few moments, I believe. That's Demis Hassabis from DeepMind. There was also a speech by European Commissioner Carlos Moedas. There was also a speech from the German Federal Minister, Frau Karliczek, because we thought it was so important to put this problem in an international cooperation setting. And since then, I've also been involved very much personally into international cooperation of this, discussing with various teams around the world about how to cooperate on this. You know, AI may be the most important lesson that I retrieved from the mission and that I am spreading is that the problem is not the technology. There are very competent people to develop the technology. You find experts around the world. The main principles are known, and we have seen these algorithms becoming so much efficient, actually, with a lot of mysteries since then to understand why they are working so well. The main problem is in the people, how we trust each other to work together, to run the experiments, to decide in which direction we should do, and how we should collaborate together. The three keywords I always use to describe the main stakes in artificial intelligence are experimentation, because the subject has turned so much pragmatic, are sharing, because the subject is all about sharing the competence, the skills, sharing the information, sharing the data, and sharing is all about the trust. Who you want to work with, who you want to share precious information with. And the third keyword is sovereignty, because it's all, in the end, about how we want to organize the sharing of the tasks between man and machine, how we want to organize the powers between public and private sector, between the various countries, and between the superpowers, and how, in particular, Europe will manage or not to take up the challenge and be in the competition about the development of AI on the same league or in the same competition as United States and China, whose development in this has been so very much impressive. Thus, AI is a problem that is for the whole society. It's not just a technical problem, it's also a political problem. Thank you very much.
Thank you so much, Cédric. We actually have 5 minutes remaining in which we would love you to ask Cédric some questions. So if those of you with a question could raise your hands, someone will bring a mic to you. While we wait for the first brave hand to go up, twice this morning so far, I've been asked kind of what we should be teaching our children in this scary new world. And as a parent of 2 yourself and a keen believer in education, what's your philosophy of parenting?
First, as the great Henri Poincaré said, the most important thing that parents can teach their children is how to become, how to get to marvel, how to become enthusiastic in front of the mysteries of the world. The capacity to become passionate about the understanding and about solving problems. I think that is the single most important thing. Then, at a more technical level, I believe every child should receive an education, a training about programming, and both my kids did from an early age. They should also get at some point, but later in the age, some understanding about the philosophy behind the algorithms. And where are the main challenges, the main techniques, what technique can be applied in which situation, and why algorithm is not just technique, is very much about the humans in this world.
Thank you so much. So a couple of questions. We have the first here.
Yeah, I have a question. Frank Luntz this morning asked 15 people to stand up and ask what they think about politicians, and the range was from, if I remember correctly, incompetent to corrupt. So I was going to ask, where do you place yourself on that spectrum? And what do you have to say to those 15 people?
Thanks you very much for the question. That is the whole point of my going into politics. People trust scientists and don't trust the politicians. When I was, after a very chaotic and complicated sequence of personal events, thinking of going into politics, and asked my mathematician colleagues, is it a good idea? The answer I got was, don't do it. You will be considered as incompetent, corrupt, or whatever. People will consider that you lose your freedom, etc. Everything you will say, there will be the suspicion that you don't say it because you think it, but because it's an instruction from a party. And still, I decided I should go in it and bring some of the confidence and trust that people gave me for my scientist career in this political career. With the idea that, okay, there are some of these new politicians coming with having made the proof that they are competent, at least in some field before in their career, that they will know at least some of the subject that they will deal with, and that have already been identified as people who speak the truth.
Lovely.
When I wrote this book a couple of months ago about my going into politics, the book is called Immersion, How You Immerse into Politics. When I started the book, I knew that the last word of the book would be trust, because that, for me, is the single most important challenge we have to bring back to the world. Trust in science, trust in politics, trust in experts, and finding the right way so that experts, politicians, and people can all discuss together.
Thank you. I think final question, Ricardo.
Thank you.
Oh, sorry. In fact, we'll take 2 questions, so if we may, we'll come to you next. Ricardo first, and then the lady in front of him.
Thank you so much. So AI is extremely powerful, and especially if I think of AI applied to life sciences. But it is as good as the data it has access to. And so my question is, if you think about genetic data about every person in the world, what are your thoughts about data protection?
And also this, I will answer both questions one after the other.
I would like to raise the point of efficiency vis-à-vis the danger of unemployment of people. And last but not least, I would like to thank you again for giving lecture for the memorial of my brother 20 years ago, Professor Flatter.
Yes, I was indeed in Beersheba for the Moshe Flato Memorial Lecture, and very proud of, as always, to honor enthusiasm and great contributions. Mathematics is a very international field with a very strong sense of brotherhood, let's say, around the world. About the data, yes. In the old, you know, the big transition that there was in the past decades about AI is that before, AI was based on understanding the nature of the phenomena strongly, causes, consequences, tree of decisions, expert systems, whatever, with the idea that to simulate, to make some efficient device, you need to understand on what parameters decisions should be taken. Nowadays, the most efficient, in many fields, the most efficient methods are based on statistical learning. Don't try to understand the big reasons, but find many examples that can calibrate. So to speak, it's the same as when you learn a language through syntax and grammar, understanding rules of conjugation and so on. That would be the first way. And the second way would be as a child, you hear adults around you talking. You don't know any of the grammar rules, but you can speak by imitation. There's actually a third big principle behind AI that DeepMind was very strong in putting together about exploring new possibilities and patterns, and that is what emerged as such a strength in their work on the Go or on the StarCraft games. But for life sciences, in which you cannot to this day, most of the causes of the phenomena are known. You know, life is such a mystery in many respects in its functioning. And also you cannot really explore for many of the phenomena, so you really are stuck to good data. What kind of drugs does this? You need good data that is as structured, ordered, and as big as possible. That is the key challenge. In France, we are working on this with the creation of a national health data platform. I know that Google also is working strong on finding the good, on putting the good tools together for health data platforms and so on. At the same time, personal life data are so private and personal. They give information about you. Privacy is an enormous issue. And often it's difficult to ensure the privacy. Some of you may remember that a few years ago, the team of Latanya Sweeney in the US made the headlines by re-identifying the file of the governor of Massachusetts within an open, supposedly anonymized list of data for health. So it's a whole field in which technique is very important, fields such as differential privacy, how you disclose exactly the amount of data that is useful and not more. Regulation is important. Never use personal data without the consent of people whose data it is about. But also openness is important. Sharing the data will bring new treatments and new medicine. Finding the right balance is enormously tricky. Depends on which culture you are working on, because the relation to personal data is a relation of trust, depends very much in the country on which you are working. And that are lots of problems that also are currently at stake. About the future of work and employment. Of course, any technological revolution carries social reworking and phenomena such as creative destruction and so on and so forth. Predictions about how it will work with AI vary enormously from one agency to another one. In fact, we don't really know where this will go and which scale. The most important for me is to set up good observatories that will observe how things are going, where are the good mechanisms to build the trust, how to organize the experiments like we did at some point for the unemployment agencies, making some good, honest, rigorous tests about which are the methods that work and which ones don't work when you want to have AI applied to help the fighting against unemployment. Globally, it's a change in which the most important question is what we want to do as a society, who we want to work with, and how we envision a world, to reach a world in which everybody find their right place with decent work. Thank you.
Please join me in thanking Cédric. Cédric, merci beaucoup. Parfait.